Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing constructions and loci. We shall begin with basic questions on locus. The diagram shows a rectangular garden divided into different areas. FG is the perpendicular bisector of BC. The arc HJ has center D and radius 20. CE is the bisector of angle DCB. Write down two more statements using loci to describe the shaded region inside the garden. So FG is the perpendicular bisector of BC. This means that FG, which is this line I'm coloring in red right now, represents the set of points that are at an equal distance from point B and point C. So therefore, the shaded region, which is above the red line, is closer to C or nearer to C than it is to B. So the first statement has already been described in the answer. Next, we are told the arc HJ has a center D and radius 20. So this arc HJ is part of a circle with center D and radius 20. So this distance here is 20. So again, the shaded region must be greater than 20 meters away from D. So we have to write here more or greater than 20 meters away from D. Finally, CE is the bisector of angle DCB. So angle DCB is this angle I'm about to color in yellow. And the bisector of the angle is again this yellow line here. And these are all points that are at an equal distance from CD and CB. So therefore, the shaded region must be closer to CD than it is to CB because it's above the yellow line. So therefore, it has to be nearer or closer to CD than CB. So the answers are more than 20 meters away from D and nearer to CD than CB. In the diagram, BL is the bisector of angle ABC and MN is the perpendicular bisector of AB. Complete the statement. So let's begin with BL. So BL is the bisector of angle ABC. This angle here. BL is the bisector of it. So the shaded region, of course, is nearer to BC than to BA. So we can just write here BC and BA. Then MN is the perpendicular bisector of AB. So MN, this red line, is equal at an equal distance from A and B. So the shaded region is nearer to B than to A, which is what they wrote in the first bullet. Therefore, our answer is the second part and complements what they wrote in the first part, which is nearer to B than to A. So BC and BA or AB is the correct answer here as well. Next, we move on to basic constructions. Using a straight edge and a compass only, construct the perpendicular bisector of the line AB. Of course, you need a compass to draw this accurately. I'm just going to give you an idea of how to do it. So your final output should look something like this. It's a line that is perpendicular on AB, and it bisects AB as well. So how do we reach this line? So first we get the compass. We put the iron part here at B, and then we put the pencil somewhere beyond half of AB. So the width of the compass must be more than half of AB. We should set the compass to more than that. And then we draw two arcs, one above and one below, like this. And then without changing the radius of the compass, we take the iron part and put it at A. And we draw two similar arcs. So they should end up looking something like this. And where the two arcs intersect, we create points. And then we use the ruler to join these 2 points together. And there we have it, the perpendicular bisector of AB. Using a straight edge and compass only, construct the locus of points equidistant from A and B. So this is exactly the same as saying construct the perpendicular bisector of AB, because we know from the previous questions that the perpendicular bisector is a line on which all the points are at an equal distance from A and B. So it's again quite the same process as the previous question. It's just a different way of asking the same thing. So first we join AB, and then, as we said before, the final product is going to look something like this. In order to reach this product, this red line, first we get the compass, we put the iron part at B, and we put the pencil beyond half of AB, so the width of the compass must be greater than half of AB, and we draw an arc above and an arc below. And then without changing the width of the compass, we now put the iron part at A, and again, we draw an arc above and an arc below. Of course, in your case, you will not have the red line in advance. You will draw the arcs and then join the points of the arcs to get the actual line, which is the perpendicular bisector. I'm just limited by the fact that I'm writing on the screen, so I cannot use a compass like you would in your exam. But this is the general idea of the drawing. Now we move on to questions that combine constructions and loci. Using a compass and a straight edge only, construct the bisector of angle BAC. So far we've been dealing with perpendicular bisector. Now we're dealing with an angle bisector. So again, the final product should look something like this, such that these two angles are equal to each other. In order to achieve that, first we put the iron part of the compass here, and we draw an arc that cuts both sides. Then we increase the width of our compass and put the iron part here and draw an arc, and then put the iron part at the other point and draw another arc. They will meet at a point. We should then construct a ray that passes through these 2 points and extends as such. This is what an angle bisector should look like. Complete the statement. The bisector of angle BAC is the locus of points that are equidistant or at an equal distance, so equidistant from AB and AC, the two sides of the angle. So equidistant from AB and AC is correct, and the accurate angle bisector was drawn as shown before. The diagram shows triangle ABC. Using a straight edge and compasses only, construct the bisector of angle ABC. So again, this is a repetition of the previous question. We said that the angle bisector is expected at the end to look something like this. And in order to achieve that, we first draw an arc. We put the iron part here and we draw the arc. And then we expand our compass a little bit. We put the iron part here. We draw an arc. And then we put the iron part here without changing the compass at all. And we draw our second arc. They will meet at a point. Then we draw the red line or the red ray, joining the point B to the point of intersection of the arcs. Hence, we obtain the angle bisector. Now, in B, we are told, draw the locus of points inside the triangle that are 3 centimeters from AC. So in order to do that, I'm going to get the ruler. I'm going to put the iron part of the compass at 0. And I'm going to put the pencil of the compass at 3 centimeters exactly. And then I'm going to draw an arc with the iron part of the compass at C. And then I'm just going to draw 3 centimeters, which is something like this. I'm going to mark the intersection with this point here. Then without changing my compass at all, I'm going to repeat the same process again, but at A. So at A, I'm going to draw an arc that is 3 centimeters away. This is, of course, not accurate at all, but you get the idea. And I'm going to mark this point here. Let me just draw it again because this will not look okay. So let's just draw it a little bit wider here. This looks kind of better. Now that we have our second point, we use a ruler and we join the 2 points together, hence obtaining a line parallel to AC and 3 centimeters away from it. So this is our second line. Of course, by chance, it met with the point of the angle bisector, but this is, again, a rough sketch. This will not actually happen in the real problem. Using a straight edge and a compass only, construct the bisector of angle BAC. So this is the same problem again. We are going to end up with something that looks like this. And in order to achieve that, we draw an arc. We expand the compass a little bit. We draw an arc. And then we put the iron part here and we draw our second arc. And where they meet, we join this point with A and we extend the ray to achieve this black ray on the screen, which is the angle bisector of BAC. Shade the region inside the triangle that is nearer to AC than to AB. So let me just extend my line a little bit here. And then we want to be nearer to AC, so we're just going to shade this part here. This is the correct shaded region. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.